Good evening, everyone.
Good evening.
I'll be taking the sessions today. So, myself Mayur, and I am in Stats one. So, I'll be teaching you Stats one. So, I just a little bit information from you guys. I wanted is have you gone through the lectures or the material provided by us to you for statistics one?
Not all of them, but few.
Few, few means how many? Or which until which week or whatever you study, because today what we are going to do is we are going to that we are going to study about week 1 to 4. So whatever the concepts are there in week 1 to 4, we are going to study about those concepts. Tomorrow we'll be doing week 5 to 8, and day after tomorrow we'll be doing 9 to 12. So week 1 to 4 actually, so if I wanted to summarize it, it is basically the types of data. Okay. So what are the types of data? Categorical and numerical data are there. If you broadly classified them, these are the two broad categories, which is numerical and categorical. And we are going to see various operations performed on the categorical and numerical data. Then we are going to see it will include week one, two, three, and in week four we are going to see the association between the two variables. So that these two variables might be numerical to numerical, numerical categorical, and categorical categorical. So like that. So I just wanted to know how many lectures or until which week you have studied. If I get to know, then it will be better for me to uh,
Almost 4 weeks.
process. Sorry,
Almost 4 weeks.
almost 4 weeks you have completed. Okay, somebody is saying week until week three. Okay, okay. So how many of you are comfortable with the probability concepts, permutation combinations? Because that will be covered tomorrow. No. Mhm. Okay. So okay, one more question to you is. Uh, what material is provided to you on, like, any questions are provided to you based on this week 1 to 4, or maybe on statistics 1? Hello, am I audible?
So I didn't get the question.
So what material is provided to you means you guys have the videos, right? Videos of stats 1. So
Yeah,
apart from that, do you have any questions to solve or something like that?
no, that is not provided by this.
Okay, fine. Okay, so I have some questions with me. So those questions are from the qualifier of the first batch. I think that is from September 2020, maybe. Okay, today I'll discuss those questions with you. And hmm, yes,
Will you provide us the questions so that we can practice more for stat and all the other subjects?
yeah, I will. I will. So today, whatever I'll discuss, maybe I'll ask them to upload it on the portal so that you can go and
Like I'm going through the videos, but not getting the type of
yes,
questions
right,
so
right,
to
fine,
practice.
no issues. I'll ask them to upload that. Okay.
Okay.
Just give me a minute. I'll just share my screen to you. Is my screen visible to you? Okay. This is also visible, right?
Yes.
Fine.
Yes.
So,
Yes.
so okay, give me a minute. Okay. So you guys have to participate because I think that will help me to understand what you guys know and what where I need to interrupt and you know elaborate the concepts more. Fine. So I'm not going to go with all the concepts from week 1 to 4 because it will take a lot of time. And one more thing is it won't help you much. So I'm just going to show you the questions. We'll try to solve that question and then we'll move forward. That will be fine, right?
Yes, sir.
Sure. So this question number one, is it visible clearly, properly, everything?
Yes.
Or should I
Yes.
zoom it a little bit? That is fine, right?
This is fine.
Everyone, okay?
Yes, sir.
Fine. Okay. So the question number one, it is basically so if you can see here, this is a question based on mean of a numerical variable, right? Okay. One more thing, if you have a data, we have two data types as I mentioned earlier. It is one categorical data, and one is what numerical data, right? So
Yes.
data we have
ऑडियो
two.
थोड़ा सा लो है प्लीज सॉरी
Okay, fine. Try to. Okay. Now is it fine?
Yes.
Okay. So we have two types of data. One is categorical and another one is numerical data, right? So I'm not going to go into the scales of measurement as of now, but let's discuss these things where I can say that categorical data, okay, what central tendencies will have or we can work upon categorical data. What are the central tendencies generally? Central tendencies.
Mean, median.
Mean, median,
Yeah, right. Mean, median, and
mode,
mode.
mode.
These are the central tendencies. So among these, for categorical variable, which type of central tendency we can apply?
Mean.
Mean categorical variable. Okay, what are the examples of categorical variable? Okay, I'll give you two examples of the categorical variable. Okay, one is name. Okay, name of a person. Another is let's say the grades of a person, right? So if I have a table, so let's say we have a class. In the class we have some, let's say 5 students are there. So first name is, let's say, Prashant. Other is, let's say, Nikita. Other is, let's say, Mayur. Then we have Deepak, and let's say we have Nitin. These are the students in the class. So let's say Prashant has scored. Is having grades A, overall grades. Okay, A. Nikita is having, let's say, uh, again A. Mayur is having, let's say, B. Deepak is having, let's say, C, and Nitish is having, let's say, A. Okay, fine. So what is name here? Name is a variable, right?
Yes.
Right.
Yes, sir.
Name is a variable. What is grades? Grades is also a variable, right?
Variable.
Correct. So what type of variable this name is? So we have 4 scales of measurement, right? So we have 4 scales of measurement. So what are those? One is nominal scale of measurement, right? Another is ordinal scale of measurement. Then we have
Interval and ratio.
interval scale of measurement, and we'll have ratio scale of measurement. Among these 4, the nominal and ordinal are applicable for categorical
Categorical.
categorical variable. Okay, and interval and uh, ratio,
Ratio.
these scales of measurement are applicable for
Numerical.
numerical data, right? Fine. Now we have this name. So we have this name. So name is what? A categorical variable, right? Correct. Why this is a categorical variable?
Because
Because
addition and multiplication sort of operations cannot be performed with categorical variables.
categorical variable, right? Because we are not there are no numbers associated with it, and even if numbers are not associated, still it is
There are
and
not
we are
able.
not able to perform
Mathematical
meaningful,
operations.
meaningful mathematical operations. So suppose, let's say I have one more one more variable called, let's say, age of a student, right? Let's say Prashant is having age as 23, Nikita is having, let's say, 27, Mayur is having, let's say, 30, Deepak is having 30, and Nit is having, let's say, 26. Okay, these are the ages of this uh, students. Okay, now one more I'll add one more variable as called as roll number. Okay, so let's say Prashant is having roll number as, or maybe let's say these are the uh, okay, let's have roll number, that is fine. Roll number, let's say we'll have Prashant is having roll number 5, Niket is having 3, Muru is having 20, Deepak is having, let's say, 10, and this is having, let's say, 15. So these are the roll numbers. So okay, so if some background noise is coming from your side, just mute yourself. Okay. So grades is also, grades is what? It is a variable, right? Correct. What is age? Age is also a variable. And what is roll number? Roll number is also a variable. I just wanted to know what type of variable these are. So name is what? Categorical variable, right? What about grades?
Categorical.
That's also
Grades is also categorical variable.
Categorical.
What about age?
Numerical.
Age is
Categorical.
a numerical. Why categorical?
We can group based upon the same number of ages.
No. Just if I'm just looking at age, so can I say that the two ages we can add, right? So
Yeah.
I can say meaningfully that let's say Prashant and Nikita's okay, or maybe the age difference between Nikita and Prashant is 4 years, right? Or I can say the addition of Prashant's age and Nikita's age is what? 50, right? But that is meaningful, right? That is meaningful, right? The difference I can say, or the, so I can able to do some mathematical operations which are meaningful, and hence it is a numerical variable. What about roll number?
Numerical.
No, roll number is a categorical variable. Even though the numbers are associated with the roll number, right? But I cannot add Prashant's roll number and Nikita's roll number, right? Can I add meaningfully? Can I say that Prashant's roll number, or the difference between the Prashant's roll number and Nikita's roll number is 2? No, right? That is not.
Yes.
Uh, that's why roll number is a categorical variable. One more example I'll give you. Maybe that will be clear to you. Let's say jersey numbers. So I think all of you follow cricket, or if you maybe you will have some knowledge about cricket. Let's say, so we have players, right? And they are having jersey number. So one is, let's say, Sachin. So Sachin is having what jersey number? 10, right? Then we have Virat Kohli. Virat Kohli is having jersey number as 18. Then we have Dhoni, who's having jersey number as 7, right? Then we have, let's say, Chris Gale, who's having the jersey number, I think, 111. I don't know. Is it correct or not? Okay. So these players, what is it, a categorical variable or numerical variable?
Category.
It is categorical, right? What about jersey number?
It is also category.
Categorical.
Why? Even though the numbers are associated with this, right? But the addition of 10 plus 18 does not make any sense. What should I convey it from this? Or can I do this operation, that 8? The difference 8 between the Virat's jersey number and Sachin's jersey number does not make any sense, right? This is meaningless. Hence, even though the jersey numbers which are having
Only the
this,
identification number, just like alphanumeric can be. This can be alphanumeric. So we can't add, delete, identify mean of these numbers.
1 minute. So this is there, right? So okay, what other examples are there from categorical variables which are again we are having the numbers associated with it? For example, phone numbers, right? So let's say I am also having one phone number, you are also having some phone number. So
Aadhaar number.
so let's say these are the phone numbers, right? Like phone number of let's say my phone number is there and your phone number is there. Can I add these two phone numbers? I can add numerically, right? But does not make adding this phone numbers any sense to you. No, right? Adding someone's phone number and the other person's phone number does not make any sense. It is meaningless. Hence, phone number is also a categorical variable. What other categorical variables are there? For example, one more example I'll take is, let's say,
Aadhaar
patient
number.
IDs. Patient IDs. Yeah, Aadhaar number, Aadhaar card number, right? So Aadhaar card number or any PAN card number. Okay, anyway, but PAN card numbers will have this uh, alphanumeric things, but Aadhaar card number is purely a number, right? So my Aadhaar card number and your Aadhaar card number does, if you add or if you subtract, does not make any sense, and hence these are the categorical variables, right? So I think it is clear to you, right? What uh, how to identify the categorical variables, correct? Okay, okay. So again, going back to this, so age is what? Age is a numerical variable, right? Okay. So let's come up to this thing, the scales of measurement, right? Okay. First thing is what? Nominal scale of measurement. So what do you mean by nominal scale of measurement? It does not have any order, right? Then we have ordinal scale of measurement. Ordinal scale of measurement is having some order in between, right? And this nominal scale of measurement and ordinal scale of measurement are applicable to which data? Category,
Categorically.
right? So can you tell me now, uh, name in this table, name is having which type of scale of measurement?
Nominal.
Nominal, right? Because these names Prashant, Nikita, Mayur, Deepak and Nitin, they does not have any order.
Order.
They do not have any order associated with it. So it is a nominal scale of measurement. What about grades?
Ordinal.
Grades is having
Ordinal.
ordinal. Ordinal. Right? Why ordinal? Because grade A is better than grade B, right? And it is better than grade C, right? This we know, right? Grade A is better than grade B, greater than grade C.
Sir,
Here
and
I
that
cannot say. I cannot say Prashant is greater than Nikita, right? Or Nikita is great. We cannot do the comparisons, right? Within Prashant and Nikita, or maybe within Prashant, Nikita, Mayur, Deepak, and Nitin. Correct?
sir,
Huh.
I have a question here.
Yes.
So if you got to, arrange them in their value, like in their ascending value, then we can also arrange the names in the ascending value.
How? Okay, if I change Nikita to the first and Mayur to, let's say, second, Nitin to third, and Deepak, what does it? Like, does that make any difference?
No.
No, right? But let's say so Mayur is currently Mayur is having grade B. If I change Mayur's grade to C, what will happen? He will degrade it to something else, right?
Yeah,
So,
right.
so
Right.
there is, or maybe if he has, so if I change the grade A for Mayur, that means he's upgraded, right?
Okay.
So so grades A, B, and C is having some order in it. I'll give one more example. Let's say you go to a store to buy shirts. Okay, what type of shirt sizes are there? So shirt size, let's say it is having in terms of this S,
And S, M,
M,
L, and XL.
L, XL, double XL, like this.
Right.
Right. So S is greater than medium. I know that, right? So no, sorry. S is smaller than the medium size t-shirt. Similarly, we have this kind of order here, right?
Correct.
Right. So if I add one more column here, let's say if I add one more column here of shirt sizes, right? And I say Prashant is wearing small, Nikita is wearing, let's say, medium, Mayur wears medium, Deepak wears, let's say, large, Nitin wears, let's say S again, suppose. So I can say, right, these shirt sizes, they have some order in it. If I
Right.
wanted to arrange according to the shirt sizes, if I wanted to arrange these shirt sizes, I can definitely arrange them like this,
Right.
right?
Hmm.
S, M, then L in the last. So I'll group S and S first, then medium and medium then L. If I wanted to arrange them in a ascending order, if I wanted to
Correct.
arrange them, right. But similarly, if I do with this, I cannot do, right, because I do not have any particular order with them, right?
Correct. Correct. Yeah.
Okay, so I know that name is having nominal scale of measurement, and grades is having what? Ordinal scale of measurement. Okay, let's move to roll number. Roll number is what? Categorical variable, right? Okay. Uh, what is the scale of measurement here?
Ordinal.
Hmm?
Ordinal.
No, it is again nominal, right? Because see, the roll numbers actually, when we provide the roll numbers, it is based on, some. So it is random, right? It does not have any. So I cannot say the roll number 5 is better than roll number 20, right?
But sir, it comes before 20, so it has a certain order.
But I can have that roll number 20 to Prashant also, and I can have the roll number to. Okay, so if it is if the roll numbers are so if some class, right, let's say if the roll numbers are not assigned uh, you know randomly, if it is assigned based on the grades achieved by a student, or maybe some other criteria, if it is there, then in that case the roll numbers will have ordinal scale of measurement. But currently, the roll numbers which I have written here, 5, 3, 10, 20, these are the random numbers. Okay. So I can have any kind of roll numbers associated with them. In that case, it is nominal. But okay. So I agreed on that, whatever your point is. So you're saying that if the roll numbers are based on some, you know, so suppose Prashant has scored the maximum marks, so his roll number will be 1. Let's say the Nikita has scored if she is a second topper. So in that case, if your roll numbers are based on the rankings, then in that case those roll numbers are considered as are having the ordinal scale of measurement. But in general, the roll numbers are not provided based on the rankings, right? These are the roll numbers which are provided randomly, or they are assigned to the persons randomly. Sometimes in the class, I think the roll numbers are assigned based on your last name, or maybe the initials of your name, something like that, right? So in that case, this roll number does not hold that particular order. So that case, the roll numbers will have nominal scale of measurement, right? Okay, fine. So what about shirt size?
Ordinal.
Ordinal, right? Okay, done. So fine, that's it. So maybe I'll just try to erase.
Rudramurthy here. And regarding that nominal and the categorical values, so are we expecting the person who does that statistics, are they should be understanding the data like whether the name should be nominals and the roll number should be uh, no- nominal again. Should they
You
have
need not to mug up. You need
they
not to
need
mug up
that
this thing.
understanding? Because say for example, if I'm not aware of the sports and the
Hmm.
jersey about the jersey numbers, I may not have the idea
Hmm.
the jersey numbers was a random number.
Hmm.
So what would happen if I understand that, or what would happen if I do that maths? Means to the statistics based on a ordinal way instead of doing the nominal way. What would be the impact if I do it in another way?
I clearly, sorry, I don't understand what you're trying to say. Let's say
Say
we
for
have,
say for example, the roll number you were saying that it is a nominal category
maybe, okay, maybe I'll take
or
the
the
jersey number.
jersey number.
Hmm.
If I'm not aware of what is this jersey number, if I'm not aware of what is it exactly supposed to mean, say instead of doing this in a nominal category, I've done the math. I mean, I've done the statistics calculation based on a ordinal method. What would be the what would go wrong?
So it's wrong, right? Like suppose, okay, so let's say this is Dhoni jersey number, right? And this is Sachin's, right? And let's say this is Virat, and let's say some this is Gale. So if you say if you understand this jersey number as a numerical variable, right? We are not talking about categorical. Categorical, if I do, then I know if you understand that this is a categorical variable, then you don't do the any calculations here, right? Because
That's what I'm saying. So should the
huh,
users, should the person who's doing this max
huh,
need
they
to
should know.
should
They
know
should know, right?
the
Correct,
should have that knowledge about this jersey
correct.
number or whatever the data that they are dealing with.
Correct, correct. Because if you are because you are enrolled in this course, right? It is basically a data science course. So what we are going to do, you are come up with some data, which is having this kind of columns, right? So
Yeah.
suppose I said, so I took an example of a simple example which was of class, right? I said these are the name of students. They are having ages, right? They are having roll numbers, right? If or maybe they are having some phone numbers, then we will have, so you will come up with the, or you will, you know, in real life data you will have this kind of uh, variables, like they should be in front of you, they will come in front of you. At that time you should understand by looking at the data and looking at these columns, right? What type of variables these are. That understanding is important because you are going to do some statistical analysis on them, right? So if you wanted to do some statistical analysis, you should know what type of data this is. Is it a categorical data? First question should be what how many categorical variables are there in this data, or how many numerical variables are there in the data. That is your first question. After that, you should know what type of scale of measurement does this have. So are they numericals, are they having ordinal scale of measurement, or they are having interval or ratio scale of measurement. If you understand that, then only you'll do some operations, right? So suppose you know these jersey numbers are nominal, so you can't do much about this, right? You can, so, and one more thing is, if you know that jersey number is a categorical variable and it is having nominal scale of measurement, you don't do any average, right? So let's say if you have calculated average of jersey numbers, right? What does that mean? It does not make any sense, right? Even though I'm able to calculate what this average of this, does that have any meaning to uh, anything? So what conclusion you will find out, like, or what conclusion you will make by finding out the average, or let's say or maybe let's say max. If you wanted to find max of jersey number, which is maximum 111, what will you say about this? Nothing. Instead of that, let's say I have this variable which is numerical age. So Dhoni's is, let's say it is 40. Sachin's is, let's say, I don't know, like maybe 48 or something. Virat's is, let's say, 34. Gale's is, let's say, 40 again. Like, okay. So if I say the average age of a player in a given data is what? So 40 plus 40 is what? So it is this, something like this, by 4. What is the calculation? So 128, 158, 162 by 4, right? So it is uh,
0.5 something.
right. So yeah, okay, 45,
40.5.
right. So what does that mean? So the data which is available to me is of older players, right? So I can say the average age of the players is above 40. That means the data which is shown to me is of those players who are about to retirement or already have retired, right? So if I include some, let's say one more player here, let's say Shubman Gill, right? So he's having age of 21. Now what my average stands now? It is 162 plus, let's say 21 by 5 now, right? So it is
Yeah,
163 plus what?
183.
So something like that, right? So what
Yeah,
impact does
183.
it have? So
Like
five.
36.
point something, right?
36.60.
Yeah, something
Yeah,
like this. So what happened
60.
if I added one player's age, which is who is like quite younger? What happened? The average age drops very low, and I can say sense from this data that there are some players who there are like along with those players. If I add some player who is younger, what will happen? The average age drops to some. What does that mean? Maybe this is the outlier person, right? Maybe this is the outlier of the data, where all the other players are having ages which are quite to a retirement age or more, they have retired already. There is some players are there who are, because why this is happening? This average is dropping to this is because mean is sensitive to outliers, right? Maybe maybe you have studied that into, I don't know, this if you have completed this lecture, you will understand what terms I'm using.
Yeah, I
Okay.
understand, sir. I understand. Thank you.
Or more, or one more thing is, let's say the run scored by this players, right? So if you add these numbers, it will have some sense, right? The average run scored by people or the average run scored by a player, something like that. So this have some sense. But if I do the average of the jersey number, what should I do with that? I cannot do anything, right? So understanding the variable categories, so I can directly remove the jersey numbers from the data from my analysis, right? Because it is not giving me any help currently, right? So how to drop these columns, how to drop this variables, which variables I need to use for any calculations analysis, that all depends on what? Depends on the knowledge of
Data.
uh, the data and how that will happen. So you should know what is categorical, what is numerical, and what scales of measurement do they have. Okay.
Thank you, sir.
Okay, so let's solve this question first. One question is there. Okay, I'm not going into details of everything maybe currently, so let's, whenever the question will come, I'll try to explain the concepts around with it. Okay. Okay, one more, okay, sorry, one more thing I need to tell is, so okay, categorical data and numerical, I think I have touched upon this is, so with numerical data I can able to find what? Mean, median, and mode. These are the central tendencies, right? And with categorical data I can able to find only what? Median and mode, right? Again, I can be able to find mode for what? Nominal data, only nominal data, right? And I can be able to do find median and mode for what? Ordinal data. Why this is so? Because median I can be able to find only when there is some order, right? Because what is the first procedure to find median? We have to arrange the
Ordering
data.
of
Yeah, we have to arrange the data in ascending order, right? Or maybe descending order, and then we are going to take the middle of it. So if the data is not ordinal, that means the order is not present in the data. I will not be able to find median, right? So to understand this, like what type of central tendencies or what type of analysis I will be able to do with the data, I need to know uh, the category of the data. So we need to see that whether this data is categorical or numerical, like that. With numerical data, I'll be able to find mean, I'll be able to find median, and I'll be able to find mode, right? Then again we have the interval scale of measurement and ratio scale of measurement. I'll talk about that later. So let's solve this question now. Okay. So can you just guys try this question for 2 minutes, and then maybe I'll give you the solution. So this is the question for you. Just try to solve that question, and I'll after that I'll just write down the answer. Okay. Did you get the answer 80%? Okay. Am I audible?
Yes, Mayur.
Yeah. Okay. So is it completed?
Yeah.
Okay. So maybe I'll write down the answer. Okay. So let's say the question is the mean annual salary paid to all employees in a company is 66 lakhs. The mean annual salaries paid to male and female employees of the company are 50 lakhs and 70 lakhs respectively. Then the percentage of female employees. Okay, or we have to find the percentage of female employees. Okay, I'll just say that let's say these are the M is represented as maybe number of male in a company. Okay, female sorry, F is represented for number of female in company. Okay, okay, then I'll have, let's say, so let's say capital N equals to M plus F, which is what? Total employees, right? Fine. So these are okay. These are the number of M is number of male, F is number of female. Okay. So I know that the mean annual salary paid to all employees in the company is 66 lakhs. Okay. So what is 66 equal to here? So let's say, so I'll have the salaries of, let's say, M male plus F female, right? So I'll just say, let's say, total salary, maybe total salary divided by what? M plus F, right? Or N. For example, here, so it is here total salary divided by M plus F. Correct? This is correct?
Yes, sir.
Okay, so what will be the total salary means what? The salaries of male plus female, right? So total salary is equals to 66 M plus F. Okay. One more information we have given here is the mean annual salaries paid to male is equals to what? 50. What does it mean? 50 equal to let's say total salary of male
Male
divided by
upon N.
M, right? Which will be equal to what? It is that's okay. I'll write like this: total salary male, right? I'll write this as total salary. Total salary male equals to what? Then 50 times M, right? Similarly, total annual salary. So the mean annual salary for female is equals to what? 70. So it will be equal to. So I'll directly write as total salary female equal to what? 70 times F. So we have equation number 1 here. This is equation 2. This is equation 3. One more thing. This total salary will be what? Total salary of male plus total salary of female, right? This is correct,
Yes.
Yes, sir.
right? So I can use equation number 2 and 3 here in equation 1, and it will become what? 50 times M plus 70 times F equal to 66 M plus what? 66 F, right? This is correct.
Correct.
I'll put equation 2 and 3 in equation number 1, and this will be my equation. Then what will happen? It will become 4 times F equal to 16 times M, right? Which will give me 1
F is
female
equal to 4M.
4M, right? Okay, I need to find what? Percentage of female, right? What does that mean? So how to find the percentage of female? Total number of female, right, divided by total persons in the company, right? So that will be equal to M plus F into 100. Is correct?
Yes, sir.
Okay. So I know this relation between number of female and number of male. What does this mean? There are the number of females are 4 times than the number of males, right? So suppose if you have 20 male in the company, then how many females are there in the company?
80.
80, right? That means this. So F equals to, I'll substitute as 4M divided by 5M into 100, which is equals to how much then?
80%.
So percentage of female in company is how much? 80%. And that I can see from here itself, right? Right? Because if 20 male are there, how many female are there? 80 female are there. So out of the 100 employees, we have 20 male and 80 female. That definitely means 80%. Correct? You can solve it in other way also, but this is what I, this is the way I have solved it. Fine. So this is application of mean. So I hope everybody has got this answer, or else you can check it later on. Fine. Okay, let's go to the question number 2. Okay, I think we have discussed this. So let's read out the question. Consider various variables that describe a used Royal Enfield motorcycle. Okay, these variables include price, mileage, model type, and model year. So their values are collected for 250 used motorcycle, which are then organized in a data table. Based on this information, we have to choose the following options. So how to draw the table? Okay, so let's say what are the variables? Price, right?
Mileage, model type, and model year.
Mileage, then we have model type, sorry, So okay, which is what? Price. We have mileage. We have model type. I'll write it as maybe empty. We'll have model year. One more variable should be required, which is what? Motorcycles, right? So because I should have like first motorcycle, second motorcycle, third motorcycle, up to how many motorcycles? We have 250 motorcycles, and we have the data of corresponding this, right? So I'll have price, I'll have mileage, I'll have motor type, model type, I'll have model year for these motorcycles, right? Is correct? So this is how my table will look like. So uh, how many variables are there in this data table?
5.
5.
5 variables. Okay. How many cases or observations are there?
250.
250.
250, right? These are the cases or observation, right?
Yes.
Right. These are the give me the just okay. So we have 250 variables here, right? Sorry, 250 observations are there. Okay, fine. So that means 250 observations are there. That means option B is correct. Okay. Okay. Can you tell me what is the type of motorcycle? This variable?
Categorical.
Numerical or categorical?
Categorical.
This is categorical, right? Because I have just written as 1 2 3, but it should not be 1 2 3. It should have something, right? Like maybe like uh, name of that vehicle or something like that, right? Maybe I'm just assuming that, but I'm not sure about it. Okay. Anyway, the information is not given to us. Let's say it can be numerical or it can be a no. It cannot be a numerical. It should be a categorical. Okay. Leave about that. What about price?
Numerical.
It will be
Numerical.
numerical. What about mileage?
Numerical.
Numerical. Fine. What about model type?
Categorical.
Categorical.
Categorical. What type of scales of measurement does it have? Scales of measurement. Whether it is a nominal or whether it is a
Nominal.
ordinal.
Nominal.
Nominal, right? Okay. What about model year?
Categorical.
This is categorical. And what type of if it is categorical, then what is the scale of measurement it should have?
Ordinal.
Nominal.
Nominal or ordinal? So let's say model year will be
Ordinal.
like 2005, 2003, 1992. So does it have no, uh, does it,
Categorical. Sorry, nominal.
if in this case, then it should have I think it should have ordinal, right?
Yeah.
Right. So I am sure that 1992 is an older model than what 2003.
2003, yeah.
Similarly like this. So according to me, it should be ordinal. But again, see this scales of measurement, right? It depends on what how we are collecting the data, right? You cannot be always sure about it. You should sense about it by looking at the data. So currently, if I'm assuming that this model year is like this 2005, 2003, and 1992, based on this, what I can sense is it should be have ordinal scale of measurement. Fine, that's okay. So what about option C? Model type is a categorical variable or not?
Correct.
Correct.
Yes.
It is.
What about price?
Correct.
It is a
Correct.
numerical. What about mileage?
False.
False, right? It is a numerical variable, right? Numerical variable. Fine. Okay. Okay, I think we haven't talked about okay, standard deviation. I think we haven't talked about that, right? It is measures of dispersion. Okay, I'll come to that later. Okay. Okay, these are the questions. All are based on this. Correlation deviation. Okay, let's talk about this question. Question number 7. So the bar chart given in the figure, question 1. Okay, can you tell me at 8 o'clock, do you have any other session today?
No, we don't.
No.
Not today, but from tomorrow we have.
Okay, fine, fine. Fine, let's see at how much time we can go today. Based on that, we'll discuss some, because maybe I am thinking of maybe we can go for 2 hour sessions and we can have one more session, maybe extra if you want. We can have one more session because you have to touch upon a lot of things, right? So maybe if you guys wanted, anyway, that's that is one more thing. Okay, question number 7.
Yes, sir, we absolutely want it.
Okay, fine. So the question number 7 is the bar chart given in figure question 1. So is it visible or should I zoom a little bit?
It's visible.
Yeah. So the bar chart given in figure question 1 shows the shoe size of a group of 50 children. Based on this information, which of the following statements are true? Okay. First of all, tell me this is what is the variable here? Shoe
Shoe
size is what?
size,
Is a variable, right? What type of variable it is?
numerical.
Numerical.
Okay. Think about it. Is it categorical or is it numerical?
Categorical.
Order categorical.
Categorical.
Categorical ordinal.
Ordinal categorical, yeah.
Right? This is a categorical variable. Why? Why this is a categorical variable?
Mean of these things doesn't matter. Based upon this category, we are grouping the students.
Right. Even though these are not these are the numbers 5, 6, 7, 8. There is no meaningful addition to this, right? Like what will this 5 plus 6 will represent? 13 is what? It's not of any sense to it, right? Or maybe 6 minus 5. I don't think it will make any sense, right? Just like we have, okay, we'll have one more example of numerical variables. For example, sugar is there, right? So I can say I have 1 kg sugar, and let's say Aman is having 3 kg sugar. So total, how much sugar is it is having? 4 kg sugar, right? So Mayur is having 1 kg sugar, Aman is having 3 kg sugar. So both of them are having 4 kg sugar. What we did here, we have done the addition, right? But whether it is a meaningful addition or not, it's a meaningful addition, right? We can add 1 kg sugar into 3 kg sugar, or we can add 3 kg sugar into 1 kg sugar, and we can say about it, right? Or maybe I can say that uh, uh, let's say let's say Mayur is having 3 kg sugar and Mayur has given 2 kg sugar to Aman. So how much sugar Mayur will left? Mayur will have. He'll have 1 kg sugar. What we did here is we have subtracted 2 kg sugar from 3 kg sugar, and it is subtracting means let's say we have taken it 2 and we have given it to someone, right? So but it is having some sense, right? It is having some sense, and hence these are. But here if you see the shoe size 6, so Mayur is having shoe size 6 and Aman is having shoe size 8.
Hello.
Can I add the shoe size 6 with shoe size 8?
No.
And if I add is also like after adding this 6 and 8, does that make any sense? No.
अरे पहले सेशन चालू होता हाँ
Can you just okay, understand this part? Okay, so if I wanted to tabulate this data, how can I tabulate this data? what will be my variable here? Shoe size. What is number of children represent? Number of children is what? Number of children is
Numerical.
no. Okay. Is it a variable or is it a
Frequency of the
noise is coming this? Okay. So this represents actually the frequency, right? Right. So there is a how many shoe sizes are there? 5, 6, 7, and 8. What is the frequency? So the shoe size 5. There are 10 children who are having shoe size 5. There are 5 children who are having shoe size 6. Here it is 20. It is 15. So this number of children it represents what? The frequency, right? It is a frequency. Okay. Based on this information, okay, option A is 5 children wear shoe size 6. Is it correct?
Yes.
Yes, sir.
Right. You can look at from here or you can look this from here also. Okay, 30 children wear shoe sizes less than 8. Less than 8 means how many? What are which shoe sizes? Either 5 or 6 or
No, it's
7.
35.
5.
So 5, 6, 7 means how many?
35.
35.
10 plus 5, 15. 15 plus 20 is 35. So this is wrong. 7 is the modal shoe size. Okay, what is the mode here? Mode
With the
represents.
highest frequency.
So which is highest frequency? 20.
7. Yeah.
Right. So and which shoe size is having highest frequency?
7.
So 7 is a mode. So is it correct?
Yes.
Yes,
Yes,
it is
sir.
correct. Option A is correct. Option C is correct. What about option D? 35 children wear shoe size larger than 6. Larger than 6 means which?
7 and
7
8.
and 8. So
Correct.
20 plus 35. It is
Correct.
35. So this is correct. 6 is the median shoe size. So okay, can I find the median for this data? Yes, because this is ordinal data and this is already in order, right? Arranged. This is in order 5, 6, 7, and 8. Okay, but what will be my median shoe size? So total how many observations are there?
4. 4 observations.
Mm-hmm.
4.
No. Observations means total frequencies. Okay, what does this mean?
50.
No.
50,
Okay, some can you please reduce the noise?
It's 20.
No. Observation, total number of observations. Okay.
50.
So
50.
okay. Huh? 50, right? Okay. I'll tell you. Like, okay, what if I wanted to write down this thing? So shoe size 5 is whereby like there are like 10 students who are having shoe size 5. What does it mean? First student, first
It's
children is having
50.
5, 5, 5, 5, 5 up till 10 times, right? This is 10 times, right? After that, I'll have 6, 6, 6, 6, 5 times, right? After that, I'll have 7, 7. How many times?
20.
20 times, right? So I'll have 20 times. After that, 8 will have 15 times, right? So total observations are how many? How many children are there? These are the total observations, right? There are total frequencies. So this is 50, right? Okay. So what will be my median? Which number will be my median? So 50 by 2 is equals to 25. So this is an integer. So 25th and 26th observation is my what?
median.
My median. So where this will lie? So first 10 children wear shoe size 5. The next 5 will
Size 7.
so 10 plus 5 is 15. Then 15 plus 20 is 35, right? So 25th and 26th observation will be lying where?
7.
Here. So 7 is what? It's my median, right? And hence option A is wrong. Fine. Is this okay?
Yes, sir.
Okay. What about range? Range of the shoe size is 4. So range is what?
1.
Huh?
Largest minus smallest.
Huh. So what is the largest shoe size?
8
8 minus 5, 3.
3.
3.
But one more thing here. This is a categorical variable, right? So do we have a range for, like, do we have a range defined for a categorical variable? Uh-huh.
We
No.
have a
No.
categorical.
No, right? So we were not able to find the range for a categorical variable, right? Again, the first quartile for the shoe size is 5. Does that make sense? No, right? Because quartiles, I think we will not be able to find for categorical data, right? Or are we able to do that? Yes, we can find the quartiles for categorical data, because if you are able to find median, so median is what? Median is what? It is
Value in the middle.
50th percentile also, right?
Center point of ordinal data.
Correct, right? But it is 50th percentile also. So have you studied about percentiles, first of all?
Yes, sir.
No.
Yes.
Okay. Okay. I'm not sure, like, whether what is, are you saying yes or no? I'm not sure. Okay. Okay, fine. Maybe I'll talk about percentiles, and then maybe we'll be able to find get these questions. This question. Okay. First of all, let's have these questions first, and then I'll go to percentiles. Okay. So this is the data, right? This is the data table. What is the, okay, how many variables are here? Okay, give me a minute. Okay, just a minute. I'll come back.
6 variables.
Is there have anyone who gave exam before this qualifier?
No.
No.
Yes, sir.
Okay, so did you pass that exam or fail?
I failed in one subject.
Which subject you have failed?
Python, sir.
Oh, Python. I think it's easy.
Yeah.
Yes, sir. Yes, sir.
No, man, also I'm a student. Also, I want to give it. I'm just talking with you because Mr. Mayur told he want to give some, right?
Okay. Hello. So how many variables are here in this data table?
6.
6.
6.
Okay, which are these? Roll number,
Roll number, gender,
gender, score
score
percentage,
percentage,
specialization, placement status, and salary.
salary.
Right? Okay. What type of variables? Okay. How many categorical variables are there? Hmm? Okay. 4 categorical variables. Okay. How many numericals are there then?
Two.
2 numericals. Okay. So which are the categorical variables? Roll number,
Roll number, gender,
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 specialization, and
specialization,
placement.
placement status.
Right. Okay. So what is the scale of measurement for roll number?
Nominal.
Nominal.
Okay. Nominal. Fine. What is the scale of measurement for gender?
Nominal.
Nominal.
Right. Nominal. Because male female does not have any order. What about specialization?
Nominal.
What about placement status?
Nominal.
Nominal. Correct. Fine. Score percentage will have this is numerical, right? So this is the
Ordinal.
numerical data. This is also numerical data. What type of scale of measurement score percentage will have? Ratio.
Ratio.
And about salary?
Interval.
No. Why interval? So okay, what is the distinction between ratio scale of measurement and interval scale of measurement? So in ratio scale of
Interval is
measurement, we will be able to do all meaningful mathematical operations, which are the subtraction, addition, then multiplication, and then division, right? But with interval scale of measurement, we'll be able to do only 2 meaningful mathematical operations, which are this addition and subtraction. Okay. One more distinction between ratio and interval is ratio scale of measurement will have absolute 0. Okay, what does it mean by absolute 0? Absolute 0 means what? The quantity where so at absolute 0 we do not have any quantity left, right? Okay, do you understand?
Yes, sir.
no, sir.
Don't understand? Okay, fine. So suppose let's say you have, okay, I'll give you one more example of let's say we have a tank. Or maybe okay, leave out tank. Sugar. Okay, so 10 kg sugar means how much sugar? Okay, some quantity of sugar is present, right? So if I have 10 kg sugar, that means some quantity of sugar is having there. So if I say 0 kg sugar, what does that mean? No sugar is there, right?
No.
0 kg sugar means sugar is not present. So that material is not there, right? Can I have minus 2 kg of sugar or minus 1 kg of sugar?
No, sir. No.
No, right? So we have started with 0, right? So 0 means what? Quantity is not present there, right? 0 is no quantity present there. 0 is that thing. Okay. So that is my reference point. From that reference point, I'm just weighing something, right? So 0 kg is what? No sugar is present. When I say 1 kg of sugar, that means I have added some sugar into that weighing machine, and that's why some quantity is present there, and it weighs 1 kg, right? But my reference point is 0 kg. So similarly, if I have 1 rupee in my pocket, that means I have something in my pocket, right? One coin is there. If I say 0 rupees in my pocket, what does that mean? No money is present, right? Can I have minus 2 rupees in my pocket?
No.
No, right? So that means that so I cannot have minus 2, minus 3, minus 4 like that. I can have 0 rupees. 0 rupees means what? No money is present there. I can have 1 rupees in my pocket. I can have 2. I can have 50. I can have something. So from where I'm starting this rupees? From 0, right? So this is absolute 0. I cannot go into negative direction. Correct. So similarly, I say, so if in a class I have, so this student, right? The student is having 80, he has scored 85%, right? Some student is scored 95, some student is scored 88. Uh, so the lowest percentage a student can have is what? 0%. Below that, can I have anything? -2% score?
sir.
Right? No, right? So like that. So 0 is my reference point here, right? I've started my percentages from 0. I started, so reference point is 0 here. Okay. Similarly, for salary, I'll have what reference point I should have? 0. I cannot have negative salary, right? I cannot have negative salary. So I think if you have watched the lectures carefully, ma'am has given the two examples to measure the temperatures. One way of measuring the temperature is what? Degree Celsius, right? And Kelvin. So degree Celsius will start from where? It will start from -273. No, no, -273, right? Where there is no temperature, right? 0 Kelvin is what? It is absolute 0, because negative like -2 Kelvin is not possible. I'll have 0 Kelvin. That means there is no temperature present.
0 degree equals to 73 Kelvin.
Sorry,
0 degree Celsius
0 degree Celsius there, but I can
to
have
73 Kelvin.
I can have -2, so that is 273 Kelvin, but I cannot leave about Kelvin currently. Do not compare the Kelvins and temperatures. Think of temperature measured in degree Celsius as one variable, and temperature measured in Kelvin is another variable. Okay, do not link those two. But what I am trying to say is, I can measure the temperature in degree Celsius in negative direction, right? Correct. I can have -5 degrees Celsius temperature. I can have -7 degrees Celsius temperature. That means some temperature is present. At -273 degrees Celsius, no molecular activities are present. That means no temperature is there. And hence, temperature when I measured in degrees Celsius will have interval scale of measurement, because I do not have, so 0 degrees Celsius is not an absolute point. It is not a reference point. What is my reference point? In degrees Celsius, it is -273. Right. But in case of Kelvin, when I'm measuring the temperature in Kelvin, my reference point is what? 0 Kelvin itself. 0 Kelvin means no temperature is present, or no molecular activities are present at that point. And hence 0 degree Kelvin is what? It is absolute 0. Hence when I measure temperature in Kelvin, it will have ratio, it is having ratio scale of measurement. But when I measure temperature in degree Celsius, it will have what? It will have interval scale of measurement. Fine. Understand? Okay. So with this, okay, what are the cases here in this table? Cases or observations?
Roll number.
Roll number.
No, no, but specifically roll numbers, right? Like CS18, maybe CS18. This is one case. This is another case. CS18B32. These are the cases. So if which are the correct options here? Option A and option D. These are not the cases. These are what? Values for some variables. Okay, which are the numerical variables? I think we have given the answer. Standard deviation, I'll come to that point. Okay. Uh, okay, I think we have covered these things. So maybe I'll solve this question. One more question. So annual summary of 5 employees in an insurance company is given here. The ratio of insurance policies sold by B and D are in the ratio of 5 to 12. Then how many insurance policies did the employee B sell? So, okay, concept here is, what is relative frequency? Relative frequency is what? It is equal to frequency corresponding to
Total.
that category, right? Divided by total frequency, or of a particular category. I will write particular category. Okay. relative frequency of a particular category is equals to frequency corresponding to that category divided by total frequency. So okay, how many total observations are there? So suppose this, I'll write it as x and I'll write it as y. So total observations or total frequency or total observations is equals to
375 plus x plus y.
375 plus x plus y. So this is addition of all these frequencies, right? So these are my total observation. Okay. With the help of this, okay. So can I able to find the total frequency or total observations, right? So relative frequency of A equals to what? Frequency of A divided by total.
375.
So relative frequency of A is how much? This 0.21875 equal to frequency of A is how much? 175 divided by total frequency, right? Or I can find it from here also, right? So let's say relative frequency of C is equals to how much? 100. Okay, tell me relative frequency of C. It's 0.125 equal to 100 divided by total frequency. So total frequency equals to how much? 100 divided by 0.125. So if you do the calculation, can you tell me what is the answer?
The addition of relative frequency.
8 times 800, right? Is correct?
No.
12. Huh?
8 I think.
How much? I think 800. If you can solve it, can somebody solve this question?
400.
How much?
Yes, 800. Yeah.
400.
How much? 100 divided by 0.125 should be 100, right? Because see 12.5, right? Just check the calculations. It should be 800. Okay, if I do the calculation with this, what will be my total frequency? So 170 divided by this point, this
800.
Again 800. So it should be same, right? It should be same. So if you wanted to calculate total frequency, I can use this, I can use this, I can use this. You'll get the same answer. Okay. Okay. So how to find the values of x and y? We have given the ratio of insurance policies of B and D as 5 to 12. What does that mean? It means x divided by y. The frequencies of x and y is equals to how much?
5 upon 12.
5 by 12.
Yeah.
Right. Is correct?
Yes, sir.
So from here I can find like 12x equals to how much?
5 by.
5y. Okay. Right. Or x equals to how much?
5 by 12. 5.
Okay. So I can use here. I can use this information here. So 800 equal to how much? 375 plus x plus
5 by 12.
y. So instead of x, I will put what? This
5
thing.
by 12.
Right. So it will be 5 by 12 y plus y. So if I solve this, so 800 minus 375, how much? It is 425 equal to
17 upon 12.
17 by 12 y. So y equals to how much? 12 into 425 divided by 7.
70.
So can somebody tell me what is the answer?
25 into 12.
How much?
25 into 12.
25 into 12.
So y is 300.
300.
300, right?
Yes, 300.
So it is 300. So y equals to 300. Okay, what mistake I have done here now? Because we have asked to find the employees of, so I need to find what? X, value of X, right? So I have found Y. So if I wanted to find X, I should replace Y equal to what? 12 by 5 into X. It does not change anything, but it will give the answer directly to X, but it's okay. So I have found out Y first. Now if I wanted to find X, what I'll do, I'll put this 300 here, right? Again, so it will become 800 equal to 375 plus X plus 300. So X equals to how much then? 125. Or else I can put value of Y as 12 by 5 into X here directly initially itself, and I'll get the answer for X, but it's fine. Anyway, you can find out the answer. So that should be the answer. So maybe you can try this out. Okay, this question. Okay, can you answer this question? We'll try this question first. I'll give you 5 minutes to solve this. Okay. So this is the histogram of the runs scored by a batsman in his career. Okay, and the frequencies are given and run scores are given, and we have to find what is the approximate mean of the runs scored by the batsman. Just take 5 minutes, and I'll come back and solve this.
Are you in line?
Okay, do you guys able to solve this?
60.
Okay, so you know how to solve this. Okay, if I wanted to tabulate this data, how should I tabulate? So this is actually grouped data, right? So this is like, okay, I'll have the run score and I'll have what? Frequency, correct? So 5 to 10, it's bin, it's an interval. 5 to 10, how many players are there? Or how many times I have scored, a player has scored runs between 5 to 10 is, sorry, 5 to 15 is 3. Similarly, 15 to 20 is equals to how many? 3. 20 to 25, oh, sorry, it's 25, right? 25 to 35, 35 to 45, 45 to 55, I think 55 to 65, 65 to 75, okay, 75 to 85, 85 to 95, and 95 to 105. 25 to 35, how many times? 1, right? Right? 1. 35 to 45,
2.
2.
1, 3, 3, 5.
1, 3, 3,
Double 2.
sorry. 45 to 55, how much?
2.
2. Again 2.
Then 1.
Then 1. Then 3, 3.
55 to 65, 1.
2, 3. And it is 5. Okay. So these are the frequencies. So how to calculate the the mean for the group data or histogram data, right? So we have to take the class. Okay, first of all, runs code is what? Is it a numerical variable or categorical variable?
Categorical.
Numerical. Why categorical? Why categorical? I can add the runs code by person, right? Correct. Runs code is a numerical variable. Okay. What type of scale of measurement it will have?
Ratio.
No, the
Interval.
other. Yeah.
Interval. Why not ratio? Because we do not. So when numerical data, if it is grouped in this, right, we have binned the data like this. In that case, we do not have the absolute scale. Okay, and hence we are not able to, we are not able to perform the division and multiplication operations here. And when the numerical data is binned like this, then it will have interval scale of measurement. You can remember this also. So whenever the data is binned like this, it will have interval scale of measurement. Okay. Okay, fine. So if this is the case, how to solve this? We have to find. So this is called a class, right? One class, 5 to 15. The another class is 15 to 25. We have to find the middle value of the class or class interval. So what is the middle value of this class interval?
10, 20,
10.
30,
Here it is 20,
30,
30,
40.
like this, right? So we have this. Now, if I wanted to find the frequency, how will I find out? So sorry, mean. So x bar equal to summation of fi upon summation of fi. So fi means frequencies, and xi here is what? The average or middle value of class of a class interval, right? And if I wanted to find it out, like, it will be equal to 10 into 3 plus 20 into 3, right? Then here
30 into 1.
30 into 1 plus
40
40
into
into 2,
2.
like
15
this.
into
Okay, and divided by summation of frequencies. That means what should I sum here? This
15.
3 plus 3 plus 1 plus 2 plus 2 plus, like this, everything. And you'll solve it, you'll get the answer 60. Okay, I'll share this question paper with you. You just guys try this question paper at your home. Okay, I'll share this paper with you. Okay. Okay. So I'll talk about then now. I think I should talk about maybe standard deviation and the concepts related to that, which is uh, the this thing, I think, percentiles, quartiles. I think I have talked about it, but let's. Okay, what is standard deviation? There are two types of standard. Okay, what is variance first? Or maybe, okay, maybe I should start like this. Maybe I'll have measures of dispersion. So measures of dispersion means the measures of variability. Like, okay, what is the deviation of the data from its central tendency? So which are the central tendencies? Mean, median, and mode. So the deviation from the central tendencies will be measured by measures of dispersion. In our course, we are going to see the deviations from what? Only mean. So what are the types of measures of dispersion are here? One is called variance, or it is called as, another is or if I take the square root of the variance, it will have it is called as standard deviation. Okay. Another thing is range. Another is interquartile range. This is called IQR or interquartile range. Okay. Maybe currently we'll talk about, maybe I think range is simple enough, right? Range is what? Range is equals to maximum minus minimum value of a data set. Okay, so this is called as range. Okay, I'll just talk about everything. So let's take one data which is, I'll show you everything from week 3 current with this data. So just look at into this data. So I have this kind of data. Let's say -2, maybe let's say minus 20. Okay, no, I don't want to have the outliers currently. Let's say, okay, let's say -2, -2, -1, 0. Okay, okay, 4, and let's say 8. This is my data set. Okay, what is the range of this data set? So what is the maximum value?
8 minus
8 minus, what is the minimum value?
-2. 10.
-2. So it is equals to 10. Okay, what is the mean? So mean will be equal to -2 -1 plus 0 plus 4 plus 8 by 5. So it is 11 by 5, right?
9 by 5.
2 point.
9 by 5.
Oh, sorry.
9 by
Okay. It should be, sorry. Should be 9 by 5. So it is 1.8,
1.8.
right? Mean is 1.8. What about median? Okay, median maybe I'll talk about later, because I wanted to cover up the percentile concepts here. So I'll do that later on. Okay, first of all, I'll go into the percentile, or maybe the discussion about percentiles. So what are the percentiles? Do you know what are the percentiles, or how to calculate the percentiles? Okay, maybe I'll talk about maybe this thing about first 5-number summary. Okay, I'll talk about 5-number summary. Okay, so 5-number summary is what? One is minimum value. Second is Q1 or first quartile or 25th percentile, right? Third is what? Q2. It is called as
Median.
second quartile, right? 50th percentile, and or median. Okay. Fourth is what? Q3, third quartile or 75th percentile. Okay. What is 5? It is maximum value. So what is minimum value here? -2, right? What is maximum value here? 8. What is Q1? Now we have to find Q1. Okay, so how to find Q1? So Q1 is called as first quartile or 25th percentile. Okay, To find out the any percentile, what are the necessary steps are there? So one step is arrange data in ascending order. Okay, arrange data in ascending order. Second step is what? Find the number of observations n. Okay. Third step is find the product n into p. So where p is equal to that percentile. Okay, that pth percentile divided by 100. So let's say in case of 25th percentile, what is the value of p? P equal to 25 by 100, which is equals to how much? 0.25. Okay, and later on what you have to find, so if this np, this product n into p, if it is integer, then you have to take average of that number plus the next number. Okay, if it is not integer, then take the next highest or next smallest integer, that observation, and that will be your value. Okay, these are the steps. I will talk, I'll take maybe I'll tell you about that here. So this is my data. I wanted to find q1 or 25th percentile. Okay, so I have to arrange this data in ascending order. So okay, what will be my first value?
-2.
-2. Second value? -1. Third value?
1.
0, 4 and 8. So it is already in ascending order. Okay, how many number of observations are there?
5.
5. Okay, what is the value of p here? 25 by 100, which is equals to 0.25. I need to find the product of n into p, which is equal to 5 into 0.25, which is equals to
1.2.
1.25. Is it integer?
No.
No. So I'll go for second observation. So second observation is what?
-1.
So this is the value of q1. Understand? Understand the flow of this? Okay.
So what is 25 here? How we got 25 by 100 here?
Because this is 25th percentile, right? So I wanted to find q1, which is 25th percentile. First quartile is 25th percentile.
Okay, got it.
Okay. So now if I wanted to find, let's say, q2, which is what? 50th percentile, or it is also called as median. So what is the step? I have to arrange the data in ascending order, which is already been arranged. Okay. So what is the value of n? N equal to 5, right? Same observations, right? Then what is the value of p here?
0.5.
50 by 100, which is 0.5. 0.5, right? N into p is equals to how much? 5 into 0.25, 0.5, 2.25. Is it an integer?
No.
No. So I'll go for third observation. So which is the third observation? 0. Which is the value of q2 or median, right? Right. So similarly, can you tell me quickly what is the value of q3? To find q3, my n into p is equals to 5 into 75 by 100, which is equal to 5 into 0.75, which is equals to 3.75, which is equals to 4. So fourth observation will be my value of q3. It's q3. So can you tell me what are my 5 number summary? q1 is what? -1. q2 is what? 0. And here it is.
4.
Okay. Okay. Okay, this is fine. So what is the range? I have already found out 8. Mean I have already found out. What is IQR? IQR is equals to Q3 minus Q1. Q3 minus Q1 is how much? 8 minus minus 2. Oh, sorry, 4. Yeah, sorry.
4
It's 4 minus is equals to 6.
5.
So IQR is 6. Okay.
4
Do you,
minus 1.
oh, sorry. 4 minus 1. Okay, sorry. 5. So IQR is 5. Okay. So this data which you have found out already, we can actually draw what a box plot. Okay. So what is box plot? Box plot is nothing but a representation of this 5-number summary. So what is the value of minimum value? Minus 2. Okay, so suppose this is minus 2, this is minus 1, this is 0, this is 1, this is 2, 3, this is 4, this is 5, 6, 7, 8. Okay, minimum value is minus 2, right? Maximum sorry, Q1 is minus 1, Q2 is 0, right? Right? Minimum value minus 2, Q1 is minus 1, Q2 is 0, Q3 is 4, and maximum value is 8. So Q2 is what? Sorry, Q2 is 0, Q3 is 4, and maximum value is 8. So box plot, so the rectangle will go through Q3 and Q1. Okay. Okay. This line. So this is what? This is max. This is Q3. This is Q1. This is minimum value, and this is what? Q2 or median. What did you understand from this? Q2 can lie anywhere between Q1 and Q3, but it need not be at the middle of this rectangle, right? Is correct, right?
Yes, sir.
Okay, fine. So this is about 5-number summary and box plot. Okay. Now I'll show you the standard deviation with the same data. So what was my data? Minus 2, minus 1, 0, 4, 8, right? So let's say my data is, so this is data minus 2, minus 1, 0, 4, and 8. What is the value? What is the mean? One 1.8, right? So this data is called as, let's say, X. So X bar is 1.8, right? We have already found out this thing, right? Hello?
Yeah, yes.
Am I audible? Okay, fine. Sorry. So you guys are cannot answer. Fine. So I to find standard. Okay, what is the formula for standard? Okay, first of all, what is variance? There are two types of variance, right? One is
Sample and population.
sample variance, and another is population variance. Okay. What about standard deviation? There are two types of standard deviation again. One is sample, another is population standard deviation. Fine. Okay. So this sample variance will be denoted by what? S square, and population variance will be denoted by sigma square. So what is sample standard deviation? It is square root of sample variance. So it is denoted by S. And what about population standard deviation? Square root of so right. So let's say my sample variance is equals to what? It's summation of xi minus x bar whole square. So square of the deviations, sum of the square of the deviations divided by n minus 1. N is what? Total number of observations. Okay. What about population variance? It is summation of divided by n. Okay. What about sample standard deviation? It is square root of s square, which is nothing but square root of xi minus x summation of xi minus x bar to the whole square divided by n minus 1. What about sigma? It is sigma square and is equals to summation of xi minus x bar to the whole square divided by n. Okay. So did you notice one thing? There is a relation between s square and sigma square, right? What is that? So the numerators are same. The only difference is where? In the denominator. So can I have any kind of relation between s square and sigma square? Yes, because I can write like this, right? S square into n minus 1, because the numerators are same. I'll just multiply s square with n minus 1. S square minus n minus 1 equals to what? Sigma square into n. Or I can say sigma square equals to what? Or maybe I can say s square is equals to what? Sigma square into n upon n minus 1. Or this is one relation between, or I can have square root of this into root of, fine. So we can have this relation between a sample standard deviation and a population standard deviation, also sample variance and the what, population variance. So for this given data, can you find now I have given you the formula, right? So I just so let's say this is my data x. Okay, so what are the data points? -2, -1, 0, 4, and 8. Just take 2 minutes to find. So first of all, you have to find x minus x bar or xi minus x bar. Then you have to find xi minus x bar to the whole square, and then you have to find let's say s square, and then you have to find sigma square. So first is to find sample variance, and another thing is to find population variance. Okay, just take 2 minutes to solve this. I'll come back. So maybe 7:55 I'll discuss the solution. Just solve it by yourself.
Hello.
Okay, did you guys solve this question? What are the answers? S square is
17.2.
17.2. Okay, sigma square
13.76.
13.76. Okay, fine. So how to find this? Okay, I know that what is the value of x bar? It is 1.8, right? It is 1.8. So xi minus x bar is how much? Minus 2 minus 1.8 is how much? Minus 3.8, right? Correct?
Yes.
Minus 1 minus 1.8 is minus 2.8.
2.8.
0,
1.8.
minus 1.8.
2 plus
This is 2.2. Here
6.2.
6.2. What are the squares of this?
14.44.
14.44.
7.8.
Sorry. Sorry.
7.84.
7.84. Here
3.24.
3.24. Here
4.84. 38.44.
Okay.
38.
So
38.
sorry. 38.44. Okay. So my formula for sample variance is what? Summation of xi minus x bar whole square divided by n minus 1. What is n here? The number of observations. So these are 5. Okay. Sum of xi minus x bar square is how much?
68.8.
68.8. Okay. So here it is 68.8 divided by 5 minus 1. So it is 68.8 minus divided by 4 equals to
17.2.
17.2. So how to find sigma square? So I can either find it out like this 68.8 divided by 5, right?
Yeah.
Because this summation of xi minus x bar square divided by n, or else I can use this relation. So s square is equals to how? What is the relation?
X square is equals to sigma square
n upon n
1 n minus 1.
So sigma square into n upon n minus 1. So, so from here I can have sigma square equals to what? S square into n minus 1 upon n, which is 17.2 into 4 by 5. Same thing, 17.2 by into 4 again it will come to what? 68.5 divided by 5. The only thing you can observe here is always you see so which value will be greater? S square will be greater than sigma square, right? It will be always be like this. Why? Because the denominator in s square is lesser than the denominator in sigma square. Fine.
Yes,
Okay, so if we are able to find sample variance and population variance, why we go for sample standard deviation and population standard deviation? That is the question. So why we go for this sample standard deviation and population standard deviation? It is because the units, right? So sample squares, sample variance and population variance will not have the same units as that of the data points, right? Or whatever the data, because it is a square of the deviations. So when we take a square root of that, it will have the same units as that of a data. For example, if I have a data kind of like this, if I have a data of speed, right? So if I have speed as kilometer per hour, right? So the speed is given as, let's say, 2 kilometer per hour, 5 kilometer per hour, 10 kilometer per hour, 20 kilometer per hour. If I find the variance, or let's say sample variance of this, I'll have the values in terms of, let's say, 25. And this is not for this data, okay? This is some random. So it will be having kilometer square per hour square. So this sample variance will not have the same unit like this as that of the data. So if I take a standard deviation of it, I'll have, let's say, 5 kilometer per hour, which will be same as that of speed, whatever the data points we are having, and it will show, or I may be able to compare, or I may not, I may be able to relate it to with the whatever the variable you are having, the original variable we are having. So suppose I'll take one example. Suppose the run scored by Virat Kohli. Okay, let's say the run scored by Virat Kohli in 10 innings is, let's say, uh, will have the average run scores is having, let's say, 50, and the standard deviation is, let's say, 5 runs. What does that mean? So average is 50 and the standard deviation is 5. That means most of the runs scored by Virat Kohli are within this range, right? Is correct? So
Yes,
Virat
sir.
Kohli scored the runs between 55 to 55, right? And if I have the, let's say, variance, so variance will be equals to 25. Can I able to relate that with the runs scored by the Virat Kohli immediately? No, right? Even though, yeah, even though it is showing the major, it is showing the dispersion, but I am not able to relate with the actual runs scored by the batsman. So if I have standard deviations along with me, I may be able to say that most of the runs scored by Virat Kohli are within this range, 45 to 55 in the 10 innings. So okay, one more thing. Let's say Virat Kohli scores have like he's having average run scored as 50 and standard deviation as 5. And let's say another player called, let's say, David Warner is there. Okay, his average scores are 50. Okay, and standard deviation as, let's say, 10. Who is the better batsman between Virat Kohli and Warner, even though the averages are same?
Virat Kohli.
Virat Kohli, right? Why?
His standard deviation is less.
Standard deviation is less.
He's more
His standard,
consistent.
More
he is
consistent.
more consistent, right? Because he scores runs between this range, 45 to 50, while the David Warner will score the scores the runs between 40 to 60, right? Because his standard deviation is 10, his standard deviation is 5. That is the practical meaning of it. Okay, even if you are not able to understand as of now, currently it's fine. If you are able to calculate it, that is enough currently. Okay. Okay, so that is the things I think. Uh, okay, I think I have covered from week 1 to 3. So maybe we'll cover more by tomorrow. Okay, so we'll have one more session from 6 to 8. So whatever I told you, look, see, this is not enough. Okay, whatever I told you today, I have tried myself to uh, you know try to touch all the concepts in week 1 to 3, but that is not enough. You have to go through the lectures once again. I'll share you this question paper. these are the questions based from week 1 to 4. I'll share more questions from week 5 to 8 and 9 to 12 as well. So today we'll stop here. We'll continue from week 3 onwards. So by tomorrow, maybe I'll be able to cover maybe week 5, 6, 4, 5, 6, 7. I'm hopeful of that. So we'll continue up to probability, and by like Wednesday we'll try to finish 2 or 3 more weeks, and after that maybe we'll have one more session. I'm not sure. We'll have one more session. Okay. Okay. Fine. Yeah. So whatever the doubts are there, we can take it tomorrow. I will try to share this question paper with you. Just go again once back and try to solve by yourself. Even though I solved it today, maybe it's not enough for you to understand everything. So just watch the lectures, go through these questions, and try to solve by yourself. Okay.
Okay,
Okay.
sir. Thank you so
Okay.
much.
Thank you. Thank you for attending the session today.
Yeah,
We'll
Mayur,
meet
thank you, Mayur.
Thank you so much, sir.
Thank you.
Thank you.
Okay.
Thank you, sir.
Okay. Bye bye. Good night.
Night.
Good night, Kunki.